when you don't have to go all the way down to 1 when you're making these choices, like we saw some examples before that were 4 times 3 times 2, essentially what we're doing then is we're finding a permutation. And when we're finding a permutation, we're finding the number of ways to order something, but we're not taking all the objects. We're only picking a group of them. So if P of n comma r, where r is less than or equal to n, is the number of permutations or the number of orderings of n elements taken r at a time, the way to calculate this is P of n comma r is equal to n factorial, and in the denominator, n minus r factorial. So for instance, if I wanted to find the number of permutations or the number of orderings of 5 objects taken 3 at a time, so P of 5 comma 3, the way I would calculate that is 5 factorial divided by the quantity 5 minus 3 factorial. If I were to write those out, I would see that I get 5 times 4 times 3 times 2 times 1, and 5 minus 3 is 2, so 2 factorial is 2 times 1. What I'd notice is that the 2's cancel out, and in effect the 1's cancel out. So this is really just 5 times 4 times 3, which is like making 3 choices. There's 5 ways to make the first choice, 4 to make the next choice, and 3 to make the next choice. So that's why we're taking the permutation of 5 objects. We have 5 things to choose from. And each time we make those 3 choices, we're going to have 1 less thing to choose from. So 5 times 4 times 3 gives me 60. So this is where you can kind of see where permutations come in. When you're making choices and you're reducing the number of things to choose from each time because they have to be different, then these permutations are going to come in handy. If you go ahead and do all 5 choices, then you would get P of 5 comma 5. In that case, it's essentially just a factorial problem. Now, to calculate this on your TI-83 calculator, you would put in first 5, the number that you're choosing from. You'd press the Math menu, then go to PRB again, and your second choice on the graphing calculator, it says NPR. That's the number of things, permutations, taken r at a time. Choose that, press Enter to paste it to your home screen, then press a 3, and then enter again. That will calculate out that 60. So the key thing to notice about this is you have to put the things that you're choosing from first, and then after you get NPR, you choose how many of them you want from that group. So if I was going to do the permutation of 7 objects, chosen 2 at a time, from our formula I do 7 factorial over 7 minus 2 factorial, which would be 7 times 6 times 5 times 4 times 3 times 2 times 1, divided by 5 times 4 times 3 times 2 times 1. That would cancel out all these pieces. And what I'd be left with is just 7 times 6. Well, that makes total sense, because if I'm choosing from 7 objects, I want to make 2 choices. That means there's going to be 7 ways to do the first choice and 6 ways to do the second choice, which gives me 42. On my graphing calculator, I'd put the 7 in first, press the Math menu, go to PRB, choose the second choice, which is NPR, press Enter to paste it to my home screen, then press 2 because I want to take and make 2 choices, enter again, and it'll calculate that 42 for you. I've been showing all the steps here so you can understand how this formula leads to the 7 times 6. How many 3-letter department codes are possible if the letters may not be repeated? I need to make 3 choices, and I get to choose from 26 different objects because there's 26 different letters, but because I'm not able to repeat those things, each time I make a choice, that letter goes out of my next choice. This is perfect for using permutations. It's P of 26, 3, and when I do that on my calculator, I get 15,600. Because essentially what I'm going to do is it's going to be 26 choices for the first letter, 25 for the second letter, and then 24 for the next letter. And that's what this calculates. To do it on your calculator, you'd press 26 first, then the Math, PRB menu. You'd go to the second choice, which is the NPR, press Enter, enter the number of choices you're going to make from those 26, and then enter again. Let's make it a little bit more complicated now. How many passcodes are possible if the codes are 3 different letters followed by 4 different numbers? So this is a perfect example to go ahead and use our permutations. Because it's asking for us to have different letters, that means that when we multiply out our choices, the number are going to drop down by 1. So I need to go ahead and make my choices for the letters and my choices for the numbers. When I choose the letters, I'm choosing from 26 letters, and I want 3 of them. When I'm choosing the numbers, I'm choosing for 10 numbers, and I want 4 of them. When I do those on my calculator, the number of permutations of 26 objects chosen 3 at a time is 15,600. The number of permutations of 10 numbers chosen 4 at a time is 5,040. So when I multiply those together, I get that there are 78,624,000 different passcodes.